Okay, in this presentation, I want to review the in-class assignment number 2, question number 3, which there were several questions on. And so this question asks for you to choose one of the data sets above and draw a normal distribution curve to display the raw data points, including the standard deviation and the z-scores. Now, although it stated t-scores, I really meant z-scores. So let's do this for question number 1. These are the scores for the skin fold measurements in millimeters: 17, 19, 12, 24, 26, 18, 15, 14, and 20. And the first thing we need to do is calculate the mean. Of course, to do this, we add the numbers, we divide by 9 because there are 9 scores. The mean of the data is 18.3. It's also acceptable to go ahead and round to the nearest whole number. Some people are confused by decimals or just don't like them, so it's okay to do that. Generally, in research, you want to keep the results in decimal form because it makes it more exact, but feel free to round. Next, we need to calculate the median, and this is the middle number, which is 18. And remember, an effective way to do this is to first arrange the scores you have in ascending order, then multiply the amount of scores you have by 0.50. In our case, this would be 9 times 0.50, or 50%. This gives us 4.5, and we can round up. And if the number of scores is odd, the median is the middle score of the distribution. If the number is even, the median is the average of the two middle scores in the distribution. So we count 4.5 or 5, and our median is 18. And the mode is the number that appears most often. And looking at our list of scores, we don't have one. And this is perfectly fine, and I wanted to see what you would do with this. Our next step is to calculate the standard deviation. And you can use your calculator, pencil, pen, or Excel. Of course, I prefer Excel. And since I've already calculated these, I can go ahead and write them down so I don't forget them. Once again, feel free to double check my calculations and round up. Even I make mistakes sometimes. I know it's hard to believe. So my standard deviation is 4.56. And this means that every 4.56 data points from my mean equals 1 standard deviation. Now, this doesn't mean that each standard deviation should be a score of 4.56 from your overall data score. Some people will confuse themselves in saying that if my standard deviation is 4.5 and my mean is 18, then the next standard deviation point should be 18 plus 4.5 or 4.56, which is 22.56. Now, this is not the case. The standard deviation describes the scatter of scores around the mean. You can also say the standard deviation provides an approximate measure of the mean distance between each data point and the mean of all the data points. You can also view the standard deviation as being an average distance each individual measurement is from the mean scores. Now, many researchers and statisticians will tell you that you can't get much from the standard deviation alone, so you have to go a little bit further. Let's calculate our z-scores. Remember, the formula for calculating z-scores is the score or value minus the mean divided by the standard deviation. So we do this for each score to calculate the z-scores, and you can see our list of scores with the corresponding z-score. We continue to do this for all of our scores to obtain a z-score for each value that we have. Now, we have all of our calculations, so let's go ahead and create our normal distribution curve. So just start by drawing a horizontal line long enough to include all your data points. Then determine the center of your line, and this is going to be your mean. Next, just make uniform points equal distances from the mean to each end of your distribution graph, and just finish it off by making your slope. You may not know how many points to make or how far to space them out, so just go ahead and get started, and you can always modify it later as you go along. And once we have this, we can go ahead and write down our mean or average in the center of our normal distribution graph. And from there, you can just simply list the remaining data on your line. There are several different ways that you can do this, and I think this is where many of you became confused. Once you have your mean, just go ahead and write down the data that you have on the equal distance lines from the mean. Don't worry if you're skipping numbers or including numbers that are not in your data list. We know that all the numbers will fall somewhere on that normal distribution line. In this first example, I simply wrote all the numbers in my data set. So, for example, our mean is 18, or 18.3 to be exact. Our next set of scores is 19, 20, 24, and 26. I know we're skipping 21, 22, 23, and 25. Although we're not listing them, we know where they are on our line. The same holds true for numbers less than our mean. Counting down from the mean, we have 17, 15, 14, and 12. Yes, we did not list 16 and 13, but we know where they are, and we know they're falling on that line. Now, if you want to list these, you can do it. You'll have to make your distance points from the mean a little bit smaller, but it can be done. Now, in doing this, you'll notice that I added the scores 10 and 11. Although these are not part of our original data set, I did this to balance out the normal distribution. All of our other scores in the data set are listed. So either way, you list your raw scores. It's perfectly acceptable to you, and it's up to you how you want to do it. Now, for me, since the previous distribution has less points and it's prettier to look at, more visually pleasing, I'll go ahead and use that one. Once we have all of our raw scores listed, we can then just write our standard deviations below those. Now remember that on a normal distribution, the standard deviation mean is always 0. And so our standard deviation we calculated is 4.56, so we list this beneath the first score. So we can say that a raw score of 19 is 1 standard deviation above the mean. A score of 20 is 2 standard deviations above the mean. And so we can continue to list our standard deviations, and generally standard deviation only extends to 3 plus or minus on either end above and below the mean. There's not usually data beyond that point, but for our example here, I just want you to understand how to respond to the assignment question. Now, this is all fine and dandy, but the scores aren't really standardized until we list the z-scores. So just as we did the standard deviation, we'll list the z-scores below the raw scores we calculated them from. So a raw score of 19 has a z-score of 0.154. A raw score of 17 has a z-score of negative 0.29. And so go ahead, continue to list all of the corresponding z-scores. Now you have completed the assignment. I hope this makes a little bit more sense than it did before, so you can visually see how I wanted you to line those up. If it doesn't make sense to you right now, hang in there, continue to ask questions, and I'll do my best to explain. Now, just for your information, I've included what the second question might look like when we plot these on a normal distribution graph. It's a little tricky in that the data does not follow a completely normal distribution, but I just want you to see how it can visualize. So that will do it for now. If you have any questions, feel free to contact me, send me an email. If it still doesn't make sense, be sure you ask questions. Take care.